Okay, so I'm going to explain the general solution to problem 5, which appeared on the Swiss TST. Okay, so this is one of the problems that decided if you made the national team for Switzerland or not. Okay, and it's meant to be in difficulty order, so it's meant to be a little bit harder than the first question, though I think in this particular exam it probably wasn't. But I'm going to explain this solution generally. So if you want to see a more like basic explanation, we have another video that's like that gets really basic. Okay, but here we're talking about a general, and we need to assume people know what induction is, mathematical induction. Yeah. So induction basically means we're trying to prove something by showing that every time you increase n, it's true. Yeah. So if something's true for n, it's true for n plus 1. Okay? And if we can show that, then we just need to show it's true for the lowest n, and then we know it's true for all n. Okay? Okay, so let's suppose we got that is true for n minus 1. Okay? So we know what the answer is for n minus 1. And we're trying to prove, so we're actually trying to prove the answer is n factorial. Okay? Makes sense? So, and to see it's n factorial, we can just let ai equals to I. So a1 equals 1, a2 equals 2, right? And we let bi equals I plus 1, okay, or ai plus 1. And so then we get this construction, so we know it's like 1, 2, 3, 4, 5, 6, 7, let's say for the 7 case. And it's like 2, 3, 4, 5, 6, 7, 8. And then every time here, you're basically just switching out one of the numbers. So you basically, so this is 7 factorial. You're switching out the 1 for 2, so it's 2 times 7 factorial. You're switching out the 2 for a 3, so it's 3 times 7 factorial, and so on until this is 8 times 7 factorial. So the common difference is 7 factorial. So this construction works in general to get a difference of n factorial. Okay, so we're trying to prove n factorial is the common difference. Does that make sense? Okay, so we assume we've done it for lower cases, and what we notice is this block here. Okay, can you see this block is actually the n minus 1 case? Alright, and the reason it's the n minus 1 case is because these differences are all the same, and then when you delete the an's, all the differences are divided by an, right? So the differences are still all the same. Does that make sense? So that means the differences by the previous case, these differences have to be at least n minus 1 factorial. Does that make sense? Yeah. Okay, so if we can show that these an's, if these an's are at least n, right? Then the whole thing has to be at least n factorial, right? Because the whole thing is going to be a product. Like this difference times an is the difference of the case that we want. Okay. So now, so let's suppose these are all less than n, right? So let's suppose these are all less than n. Yeah. So for example, let's suppose these are less than n. So it's like it could be like n minus 1 or something, right? Yes? So that's the biggest number less than n we can have it, yeah? And let's suppose bn is n, yeah? So it could even be more than n, okay? But you see if it's more, the difference will be even bigger, okay? But if it's just n, okay, then the difference here, this difference, what's this difference here? Yeah?
Difference is B1, B2,
B1, B2, Bn minus 1, right? Okay.
It's the same thing.
Yeah, it's the same thing. Okay, so if that's the difference, so so this could be even bigger. So the difference could even be bigger than this, right? Yeah. Okay, but what happens? So this is n minus 1 times b1 up to bn minus 1, right? What happens if you count backwards? So if you go backwards, right, by 1, so this difference is the same difference for all of them now, right? So if you go back by 1, you get n minus 2 times b1, b1, b2, b3, up to bn minus 1, right? Does that make sense? Okay. So does that make sense? Yeah, so what happens if you go up by 1 again, right? Then you get to n minus 3, yeah? Yeah. But the problem is how many rows are here? How many rows are here, you know? Yeah, but you can still know. Look, so there's n minus 1 numbers, and you need to change them all, right? So you need n minus 1 moves, yeah? So there's a total of n things up here, right? Yeah. So basically, if you go back n minus 1 times, and you start with n minus 1, then you're going to end up at 0, right? You see? If you move the same number of, if you subtract the same number of things as there are here, then you're going to get 0, okay? But you're not allowed to get 0, you see? Why not?
Because it's not positive.
Yeah, product of positive integers is positive, yeah? Okay? And so you can't get negative either, and if the difference was bigger, you would just get to negative, yeah? And if this number here was smaller, it would also get to negative faster, right? So can you see that proves that this number actually has to be at least n, right? And then we're done, yeah? And that's called the induction step, okay? Does that make sense? So the induction step says counting keeps your thing true, right? The only thing we need to do now, so I'm not going to actually do it, but it's the base case. So base case is to prove the initial thing is true so you can actually keep counting from something, right? Okay, so if you watch this far, this will be a little bit of a reward for you because it says n is greater than or equal to 4, right? So most people will take n equals 4 as the base case, okay? But that could be slightly tricky because that difference is 24, right? And then you don't know how to eliminate the things lower than that, right? So actually, something interesting about this problem is you could actually take the base case to be n equals 1, okay? So then what you're actually proving is you're proving it's true for n greater than or equal to 1, but obviously if it's true for greater than or equal to 1, then it's also true for greater than or equal to 4, right? Alright, any questions about that? So you can see like that looked pretty complicated, right? But if you understood all the basic stuff, it's actually pretty simple, yeah?